The LHC is back again with a new sensation. For the first time ever, there is proof of the decay of the famous Higgs boson in two bottom quarks. What? Are you serious? What does this mean for the future, and why is this such a great sensation? Welcome to Clixoom Science Fiction. If you don't want to miss any of our 3 new videos on science every week, subscribe to our channel.
1, 2, 3.
So, this is what they look like. The data tapes of Cern, the Large Hadron Collider, short LHC. There are 600,000 proton collisions on it that were close to the speed of light. 30 minutes of running time on the LHC. The data is recorded among others here at the Atlas detector, and in June of 2012 the Higgs boson was first discovered in this data. An absolutely crazy particle. Through this particle the existence of the Higgs field has been proven. It provides everything with mass, the attribute of matter which leads to the space-time curvature and therefore pulls us to the Earth, for example. Although gravitation is not a force, it is the curvature of space-time. And the attribute of the matter, mass, which leads to the curvature, is provided by the Higgs boson. This all happened at the LHC, one of the biggest and most expensive machines of mankind. It cost about $4.75 billion, a ring with a length of approximately 27 kilometers, equipped with strong detectors in which protons or lead ions collide at a speed close to the speed of light. During these collisions the particles decay into their components, and if everything goes well, those are tracked down by the huge detectors. Over several decades a standard model of the elementary particle physics was created. Using the LHC and its precursors, this model was proven over and over again with its quarks, leptons and bosons. But proving the breakdown of the Higgs boson into two bottom quarks with the standard model was tricky, because these particles also result in other processes of decay, and that even though Higgs bosons usually decay into those two particles. According to the standard model, Higgs bosons break down into these two quarks 60% of the time. But Kerstin Techman from the Atlas detector at Cern had this to say about the matter. LHC collisions generate great amounts of bottom quark pairs. This makes it really difficult to filter out those that are actually from the decay of the Higgs boson. So how can we identify the decay of the Higgs boson? Artificial intelligence, meaning algorithms that can adapt, would be the solution. They were looking for decays in the data in which a Z boson or a W boson appears, and this has now worked. This proof is a milestone in the research of the Higgs boson. We have now observed a couplings of the Higgs boson with the heavy quarks and leptons of the 3rd generation, and also the different important kinds of how these particles are created. That's what Carl Jacobs said, who is a speaker at the Atlas. This has again shown that the standard model of the elementary particle physics is true, and also the Yukawa coupling, which means the exact coupling of the Higgs field with the loaded elementary particles like quarks and leptons, which give them their mass. Wow, we have come a little closer to one of the biggest mysteries again. Thanks to our experiments, we are getting closer and closer to the nature of the Higgs particle, the particle which counts as a portal to a new kind of physics, said Eckhard Elson, Cern Director of Research and Computing. Slowly, the research teams at Cern are advancing to an area where a new kind of physics could be hiding. Wow! Would you like more topics on physics like this one? About theories on the end of the universe? Click here. Let us know what field of science sparks your interests in the comments below. Thank you very much for watching. Stay tuned and see you soon.